We've been learning about trigonometric functions with right triangles. In this section, we want to learn about the law of sines. The law of sines can be applied only to the oblique triangle. Oblique triangles are the triangles which are not right triangles. There are two types of oblique triangles. Those are acute triangles, so none of them are obtuse angles greater than 90 degrees. The other one is obtuse triangle. One of the angles should be an obtuse angle to be an obtuse triangle. Let's say this angle is A, this angle is B, and this angle is C. Then when we discuss the law of sines, there is a way we label the side length. Here is angle A, which is denoted with a capital letter. Then opposite side length is denoted with small alphabetical character. And the same, this is capital B, and small b is written beside the side which is opposite to the angle B. The same with C. That is the rule we label the angles and corresponding side length. Let me describe the law of sines. Law of sines is sine of A over A equals sine of B over B, and that equals sine of C over C. So ratio of the sine of the angle and opposite side length are the same within the same triangle. That is the law of sines. You have to remember this formula. We use the law of sines to solve the triangle. When we say we solve the triangle, that means we find the missing side and angles. Always keep in mind that law of sines can be applied only when we know at least one fraction, meaning one angle and corresponding side length. And additional information will be either one more angle or one more side length related information. There are two cases we use the law of sines. The first case is angle side angle or angle side case. In this case, we know two angles and one side length are known. In this case, there is a unique solution. So in this case, as the law of sines is working very nicely, this was the law of sine. I said two angles and one side length are known, so this pair is known, and one more angle is known. Let's say this is known, and then angle C can be calculated. That means all three angles are known. We can calculate this angle because we know A plus B plus C equals 180 degree. And what A and B are known, so we can just solve for C. In this case, we just think about two cases. We just think about this equation to get the side length B, and we get this. We have this equation to find the side length C. The circumstance is something like this. One side length is known, and the two angles are known, and then this part is implicitly known. So all three angles are known, essentially, and the problem is about finding two missing side lengths. The other case is so-called ambiguous case, which is much harder. That is side-side angle case. In this case, the possible solution may not exist, so none. It may be unique, or it may be two. Let's rewrite the law of sines. Then that is sine of A over A, sine of B over B, and sine of C over C. We are applying the law of sines, so at least one pair. So this fraction is just a number, and in this case, one other side length is known. This is known. So if there is only one triangle which exists, which might exist or might not exist, then the case looks like this. Two side lengths are known, and one angle is known. In this case, the way we solve the problem is this is a number, this is a number, so we have to find the angle B. This is the first step. So find angle B, and then using that information to find angle C, and then find the missing side C. So once we find the angle B, then we know two angles, so we can calculate C. But at this stage, we may have no angle, or one angle, or two angles. Let's see why that happens. Firstly, what we know is a sine of A, sine of B, sine of C, all of them are positive numbers. Why is that? That is because the graph of sine function look like this. And the internal angle ranges between 0 and pi. In that region, the sine value is positive. So the numerator are positive, and denominator, all of them are side length, and so we can say that the all fractions are positive. Let's consider what problem it can have. Sine of A over A equals sine of B over B. And what we want to do is we want to think about sine of B. To do that, we have to multiply by B on both sides. Then left side is B times sine of A over A. That is sine of B. At this stage, if B is too large, the side length B is too large, then B times sine of A over A will become 1. So that means no such triangle. And when we think about sine of B, again, the same equation, B times sine of A over A. Then there are two possibilities. Let's think about the graph of sine again. The graph of sine looks like this. We just think about 0 to pi. And we know that internal angle ranges between 0 and pi, strictly greater than 0 and less than pi. If you try to find b, the b ranges between 0 and pi. It is not minus pi over 2 to pi over 2. This is not the range of sine inverse function. So if we think about the sine inverse function, it'll give you a unique number. Unfortunately, the angle ranges between minus pi over 2 to pi over 2. So that doesn't have to be the answer. And what we are looking for in when we apply the law of sines is we are looking for the angle whose sine value is the same as sine of b. Let's say this is sine of b. Then that is symmetric with respect to pi over 2. So we always have two cases. Depending on the larger value, when we add the given angle A with this larger valued angle, the sum of those two may be more than 180 degrees. In that case, we have only one solution. If the sum of this angle A and this angle is less than 180 degrees, then we have two angles. Right now, it should be pretty hard to understand. So we will work through those problems with the examples. You can stop this recording and you can read the question, and then I will start to explain. In this problem, when we simplify the problem, it looks like this. We have a triangle. The A is Los Angeles and B is Phoenix. And there is a satellite here. They're giving you the angle between the city and satellite, that those are 75 degrees and 60 degrees. The distance between Los Angeles and Phoenix is 340 miles. And this is A, this is B. The problem is how far is the satellite from Los Angeles. So we are looking for the side length B. If you look at the problem, we notice that the side length C is given, and what I said was whenever we think about the law of sines, one pair of side length and corresponding angle are given. So we have to use this angle C. Let's calculate the angle C. Two angles are given, so the angle C is 180 minus 75 minus 60 degree. And then you are getting 45 degree. So we calculated this angle, that was 45 degree. And then we are getting sine of C over C. And then we have to look at the problem. This is, we are looking for the side length B, so that must be associated with the angle B. Therefore, the part of the equation we have to use will be sine of B over B. Currently, this side length B is unknown, but all other three are known, so we can calculate it. Let's do substitution. The angle C is 45 degree here, and the side length C is 340, and that equals sine of a larger B, which is 60 degree, over B. So we multiply by B on both sides, then we get B times sine of 45 degree over 340 degree. That equals sine of 60 degree. Those will cancel each other. And we multiply by the reciprocal on both sides. 340 over sine of 45 degree. So B equals sine of 60 degree times 340 over sine of 45 degree. In the problem, we have to write the answer with a natural number. That means we have to use calculator to approximate. In this calculator, the current mode is radian mode, so I will change it by using the RG button. Now it became a degree mode. Let's put the information. Sine of 60 degrees, so 60, then sine. Then we have to multiply by 340 times 340, and then divide by 45 degree of sine, divided by 45 of sine, and then that is 416.41 and so on. We have to round up to the natural number, and this is less than 5, so the final answer is 416 miles, meaning the distance between Los Angeles and the satellite is 460 miles. The next example is angle, side angle case. We want to solve the triangle. Then we have to approximate to 1 decimal point. Side length C is given as 80.4, and the angle A is given as 20 degree, and angle C is given as 25 degree. The first thing we can notice from this problem is this side and corresponding angle are known, so we can apply the law of sines. And two angles are known, so we can calculate this angle. Angle B is 180 degree minus 20 degree minus 25 degree. That is 135 degree. We think about law of sines. The angle A is 20 degree over side length A is unknown, and sine of B is 135 degree over the side length B is unknown, and then we have sine of 25 degree, which is given as angle C, and the corresponding side is given as 80.4. So we will figure out A by using this equation, and then we will figure out the side length B. Let's use sine of 20 degree over A equals sine of 25 degree over 80.4. We have to solve for A, so we multiply by A on both sides. Then A times sine of 25 degree over 80.4 equals sine of 20 degree. We want to solve for A, so we will multiply by the reciprocal on both sides. you will use your calculator again. That I will not show you how to use calculator again because I already demonstrated with the previous problem. So this one is 1. And so A is sine of 20 degree times 80.4 divided by sine of 25 degree. If you put the information in your calculator, then you will get 65.06680, and we have to approximate to 1 decimal place, so that'll be 65.1 because of this number. Let's find B. This time we will use sine of 135 degree over B equals sine of 25 degree over 80.4. So we do the same thing. We multiply by B on both sides, and then we will multiply by the reciprocal. Sine of 135 degree equals sine of 25 degree over 80.4 times B. We multiply by the reciprocal on both sides to get 80.4 over sine of 25 degree. So the B, those will cancel each other. So B will be 80.4 times sine of 135 degree over sine of 25 degree. You have to use your calculator. Then your calculator will give you 134.5218 and so on. We have to approximate to 1 decimal place. So because of 2 is less than 5, we have 134.5. The next example will be harder because that is ambiguous case. Which is side-side angle. In an ambiguous case, we can produce 2 triangle, 1 triangle, or no triangle. The first example is side-side angle case, which produce 1 solution. In this case, the one of the possible angles will be dropped. We will know why. Solve triangle ABC, where angle A equals 45 degree, and corresponding side A is 7 square root of 2, and the side length B equals 7. If you cannot find the exact answer, then approximate the answer to 1 decimal point. Let's assume that there is a triangle and just visualize the information we are having. This is angle A, this is angle B, this is angle C. The angle A is given as 45 degree. And side length B is 7. The side length A is 7 square root of 2. So we don't know the angle B and angle C and side length C. By looking at the triangle, what we know is we can apply the law of sine because this is an angle and this is a corresponding side. That pair of information is given here, so we can apply the law of sines. When we apply the law of sines, sine of A over A equals sine of B over B equals sine of C over C. Currently, what's given here is sine of A over A and this side length. Let's do substitution, and we will start with this pair. Sine of angle A was 45 degree, and the side length is 7 square root of 2. And we don't know the angle B, so sine of B over the side length B is 7. So we multiply by 7 on both sides. Then on the right side, we have sine of B. Those will cancel each other. 7 square root of 2 is 7 times square root of 2. So 7 and 7 will cancel each other. And on the left side, we have sine of 45 degree over square root of 2. So we can say that sine of B equals sine of 45 degree times 1 over square root of 2. We know that sine of 45 degree is 1 over square root of 2. So we can write that down as 1 over square root of 2 times 1 over square root of 2. That is 1 over 2. From here, what we know is we have to solve the equation sine of b equals 1 over 2. So we have to think about the angle ranges between 0 and 180 degree, whose sine value is 1/2. It's a little bit different from thinking about the inverse sine function, but we will think about inverse sine function first. Sine inverse of 1/2 equals, we know that is 30 degree. 1, 2, square root of 3. Here 1 is opposite and 2 is hypotenuse. So this is hypotenuse and 1 is opposite to 30 degree. So inverse function will give us 30 degree, and we know that satisfies this condition, minus 90 degree to 90 degree, which is the range of inverse sine function. Let's think about the graph of the sine function. This is 1 and this is -1. This point is -90 degree. This is 90 degree. And this is 180 degree. I have to explain the subtlety here. Zero to 180 degree is the possible internal angle range of a triangle. And we also know that from minus 90 to 90 degree, that is the range of y equals sine inverse of x. So when we think about what we did to figure out the inverse sine function, which was indeed 1/2, this is 30 degree and this is 1/2. We just think about the angle which satisfies the equation sine of b equals 1/2. And then what we have to think about is the angle ranges between 0 and 180 degree, whose sine values are the same. Let's visualize the circumstance. This part is the range of y equals sine inverse of x. And we already got sine inverse of b is 30 degree. Here is the 30 degree. And then what we have to think about is the range of the possible internal angles in the triangle. This time that becomes this blue region, which ranges from 0 to 180 degree. When we used sine inverse of 1/2, we missed the angle in this region. As we know, the sine is positive in the first and second quadrant. There is another angle which satisfies the same equation. That angle has the same reference angle, 30 degree. And that angle is apparently 150 degree. So we have two possibilities. Those are 30 degree and 150 degree. So what I was saying was a sine of 30 degree equals sine of 150 degree. That is 1/2, the same value. When we have two possibilities, we have to check one by one. Checking the validity is the same, pretty simple. B is 30 degree. We know the angle A value and angle B value, so we have to get the angle C value. Then angle C is 180 degree minus 45 degree minus 30 degree. If we calculate it, then that is 105 degree. So we know all three angles, and we can apply the law of sines. And we know the angle A is 45 degree and the side length A is 7 square root of 2. So sine of A over A equals sine of, this time we want to think about C over C. Then sine of A, the angle A was given as 45 degrees, so sine of 45 degree over the side length A is 7 square root of 2 equals sine of C is 105 degree over C is unknown. all we have to do is we just solve for C. We multiply by C on both sides, then C times sine of 45 degree over 7 square root of 2 equals sine of 105 degree. These will cancel each other, and then we multiply by the reciprocal on both sides to get C by itself on the left side. So those will cancel each other and become 1. So C equals sine of 105 degree times 7 square root of 2 over sine of 45 degree. You will use your calculator again, then it'll be 13.52296 and so on. We are supposed to approximate on up to 1 decimal point, so it'll be 13.5. In this case, the angle A is 45 degree, angle B is 30 degree, angle C is 105 degree, and the side length A is 7 square root of 2, and side length B equals 7, and side length C is approximately 13.5. In the second case is when the angle is B is 150 degree. What we did in the previous case was we calculate the angle C. So what you have to do is you think about 180 degree minus angle A minus angle B, which is 150 degree. If you add these two negative numbers, then that will be minus 195 degree. So when you add them up, that will become negative. There is no such negative angle, so that is impossible. That's the reason. In this case, the solution is unique. The next case is side-side angle two-solution case. We have an information. Solve the triangle. ABC if angle A equals 43.1 degree and side length A is 186.2 and side length B equals 248.6. Let me write the law of sines first. Sine of A over A equals sine of B over B. That equals sine of C over C. here, the first thing you have to observe is this angle. Pair of angle and side are given. That's the reason we are using the law of sines. So sine of A is 43.1 degree over A is 186.2 equals sine of B over the side length B, 248.6. So what we want to do is we want to solve for B, and then we will apply the inverse sine function to get the reference angle. So let's multiply by 248.6. So sine of B equals 248.6 times sine of 43.1 degree over 186.2. Then to get the reference angle, we will use sine inverse. So what we are doing is B equals sine inverse. Actually, it is reference angle of B is sine inverse of 248.6 times sine of 43.1 degree over 186.2. Let's use the calculator. We have to make sure that the mode is degree mode. Currently that is in the degree mode. So let's put the information 248.6 times 43.1 of sine then we have to divide by 186.2, evaluate it, and then we have to use inverse sine, second and sine. That gives us about 65.8 degree. Again, if we think about the graph of sine function, this is the range of inverse sine function. This is the range of the internal possible internal angle ranges of a triangle. This is 180 degree. This is 90 degree. This is minus 90 degree. What happened was we used the calculator to evaluate the inverse image of the value, and then we got 65.8 degree, and what we are looking for is the inverse image of sine B. This value is sine of B, and so there is another angle here. We can get this angle by thinking about the reference angle. Again, when we visualize, here is, we have 65.8 degree, and there is another angle here. This is sine function. Sine is positive in the first and second quadrant, and this is the possible internal angles range. So this is the reference angle. So we relocate it here, then that is 65.8 degree, and this is 180 degree. So this angle is 180 degree minus 65.8 degree. That equals 114.2 degree. So we have two possibilities. So we figured out this angle. This angle is 114.2 degree. So this angle was sine inverse of sine of B. So I said that is the reference angle of the angle B. The way we think about the validity is simple. There are two cases. Case 1 is angle B is 65.8 degree, and case 2, angle B equals 114.2 degree. So the missing angle in this problem is angle C. The angle C in the first case is 180 degree minus 43.1 degree minus 65.8 degree. The angle A was given, and we figured out the angle B. So when you do it, you get 71.1 degree. So this is a valid angle as an internal angle of a triangle. So this is the valid solution. We check the validity in the same way. We have angle C, then we have 180 minus 43.1 degree minus 114.2 degree. If you use your calculator, then that is 22.7 degree. Again, that is the valid angle. So both cases are fine. That's the reason we have two solutions. Let's work with that. In case 1, the angle B is 65.8 degree. And we already know the angle C is 71.1 degree. And angle A was 43.1 degree. We also know the side length A, that is 186.2, and the side length B was 248.6. So all we have to do is what is the side length C. You can choose either this pair or this pair, it doesn't matter, but I will decide to choose this pair to solve the problem. Sine of 43.1 degree over A is 86.2 equals, we are looking for this. That is sine of 71.1 degree over the side length C. So what we are using in the law of sine is sine of A over A equals sine of C over C. So we multiply by C on both sides, then C times sine of 43.1 degree over 186.2 equals sine of 71.1 degree. And we multiply by the reciprocal, 186.2 over sine of 43.1 degree. So do the two will cancel each other. So C equals 186.2 times sine of 71.1 degree over sine of 43.1 degree. You will use your calculator, then C will be approximately 257.8191 and so on. We approximate to one decimal place, so we get 257.8. So the missing side length C is obtained, that is 257.8. So we solved the triangle for one of the cases. In case 2, the angle B was 114.2 degree, and angle C, which we already calculated, was 22.7 degree, and angle A is 43.1 degree. And B was given in the problem, so that is 248.6. And we are looking for C, and A was given as 186.2. I will use the angle A related information. We will use sine of A over A equals sine of C over C. So that is sine of 43.1 degree over the side length is 186.2 equals sine of angle C is 22.7 degree over C. So we will multiply by C on both sides and then multiply by the reciprocal. C times sine 33.1 degree over 186.2 equals a sine of 22.7 degree, and we multiply by the reciprocal 186.2 over sine of 43.1 degree times, just we do the same thing on the both sides. So this will be 1. So the side length C can be obtained by calculating 186.2 times sine of 22.7 degree over sine of 43.1 degree. So we will use calculator, then we get 105.2. So this C is 105.2. That is the complete solution. What we wanna mention is this. When you think about the two possibilities, one angle is acute angle and the other angle is obtuse angle. And so in this case, it will produce the obtuse triangle. In this case, depending on the value of this angle, it can be acute or obtuse triangle. In this case, all the values, angle values are just the acute angles. So the final triangle shape will be like this. It doesn't have to be accurate, but it should be an acute triangle. But in this case, angle B is obtuse angle, so the triangle will be an obtuse angle or triangle. The last one we wanna think about is no solution case, side-side angle case. We have a problem solve triangle ABC where angle of A equals 42 degree and the side length is 70 and side length B equals 122. Now again, the first thing you have to observe is the pair of angle and side length is given, so we can apply the law of sines. In the next section, we will learn about law of cosines, so you should be able to figure out whether you can apply the law of sines or law of cosines. So we will use the law of sines. So sine of angle A over the side length A equals sine of B over the side length B, which is 122. Let's multiply by 122 to get sine of B by itself on the right side. Then that'll be 122 times sine of 42 degree over 70. That equals sine of B. If you put this fraction into the calculator, then that's approximately 1.2. So what it indicates is the sine of B is approximately 1.2, which is strictly greater than 1. So this is impossible. So there is no solution. But you may use the calculator, so you may decide to put the information to figure out the reference angle of B. Then sine inverse of 122 times sine of 42 degree over 70. If you put this information in your calculator, then it'll give you an error. So there are two ways to check it. That's all for the law of sines.